Right, this is our third topic in our momentum chapter, and we're going to talk about open versus closed systems and what happens to the center of mass of a system during a collision. Now, we've talked about open versus closed systems before in the chapter on work energy. We defined an open versus a closed system. So if you want to, you can pause the video and get the handout that I gave you back in that chapter. And one of the things that we said was if we look at a system, if we can draw a dotted line or a line around the system, if there are external forces, that is not a closed system. For a closed system, all the forces have to be maintained internally. So let's look at this again. This time we're going to look at it with momentum. So I've got a couple of practice AP questions here. We have block X slides along a horizontal surface with a speed of VOX, so an original velocity, towards block Y, which is here. So we have block X, we have block Y. As shown in figure 1, after block X collides with block Y, the two blocks remain stuck together and travel at a velocity Vxy as shown in figure 2. Here, frictional forces are considered to be negligible. Which of the following claims is correct regarding the momentum of the system containing only block X and the system that contains block X and block Y? Now, one of the things we have to understand is when we talk about just block X, we're talking about at the time of collision. So let's redraw our blocks here. So here's block X. And this is at the moment that it collides. And so what I'm going to do is I'm going to do a dash line around. And then I'm going to do a block X and Y over here. So if we're doing X and Y. And I'm going to do a dash line around this. Well, let's look at the both boxes to start with. So at the moment of collision, now if friction was not negligible, this would be a different free body diagram. But what we want to do here is we basically want to do a free body diagram. So if we had friction and we're moving this way, we would get friction that's acting opposite of our motion. And that would be a different story, but we're ignoring friction. So right now, what we know is that block X is going to exert a force on block Y, and block Y is going to exert a force on block X. So here we have the force of Y on X, and here we have the force of X on Y. And if we go back to our Newton's third law, we know that these forces are equal and opposite, and they are both contained within our system. But now over here, we have a single block, and we're going to have that. So this is the force on X by Y. Even if you drew this and you drew that the arrows were out, if you saw that these were equal and opposite, that's an indication that this is contained within the system. So this is going to be a closed system. But over here, there is only, because we're only considering block X, and we have this single force, this is going to be an open system. Remember we said on our handout that anytime we have a single external force, so this is our only external force because we're ignoring friction, it's almost always going to be an open system. And here, because we have two and they're equal opposite, we're going to be closed. So what about the center of mass? So we have, actually, we can look at block X and block Y here, and we see that there's a center of mass between them, even though they're not touching. You can take an entire system, even if the objects are moving, and you can calculate at any given point where the center of mass is going to be. Well, the rule of thumb is that for closed systems, the center of mass doesn't change. So on a closed system, the center of mass doesn't change. It stays constant. And that's a common question for AP. They want to know what happens to the center of mass for a system. They'll look at it. And basically, if it's a closed system, it's going to be the same. It's going to be constant. Over here for an open system though, or if you had an open system, that center of mass can change. So before you can decide if the center of mass is changing or not, you basically have to define if it's an open or closed system. And that's usually the question they ask. They'll say, does the center of mass change? And if you define that it's closed, the answer is no. And if you define that it's open, the answer is yes. All right, let's look at another sample problem. I'm just going to slide my camera down. All right, here we go. We have block X and block Y are tied together by a rope. The system containing block X and block Y is dropped above Earth's surface in the orientation shown in the figure. Block Y has a larger mass than block X. Which of the following claims is correct regarding the momentum of the system containing only block X and the system that contains block X and block Y? So here we go. Let's redraw. I've got block X, and then I've got block X and Y. Whoops, let me draw that in blue. Trying to kind of keep my color coding consistent here. Block Y was larger. Okay, so I draw diagram around what are my forces. I assume we're ignoring air resistance. So if up is positive, I'm going to have the force of gravity acting down, and I'm going to have tension pulling the block that way. So this is definitely an open system. I have two forces that are going to go outside of the box. And again, just as a refresher, how do I know that this arrow doesn't stay inside the diagram? The object that's causing the force is not located inside the box. So the same thing for up here. How do I know this box extends? The object that's causing this force is not inside this box. And so you actually have to draw that arrow outside. All right, what about over here when I draw? So in this case, I have the force of tension, switch colors here. I have the force of tension. So this is pulling this way. I have the force on X by Y, and that's tension, actually it'd be tension. And I have the force of tension on Y by X, and those are equal and opposite. So we can see those are internal forces now. We don't have to worry about those. But what about gravity? These are falling. Yep, they're dropped above the Earth's surface. So now I have the forces due to gravity, and those are still external forces. So that means that this is also going to be open. So the correct answer here is these are both open. That means that for this, the center of mass would not be constant. Neither of these are closed systems, so the center of mass is not going to stay constant. Now, what would happen if I define this as a block X, blocks Y, block X, blocks Y Earth system? That would change things because now all the objects lie inside my system. This would now be a closed system, and the center of mass would be constant. So it all comes down to how you define your system. Again, kind of a review of what we did in the Chapter 7 work energy, but you'll see these questions from time to time pop up on your multiple choice. Okay, see you in the next video.